Okay, so chapter 2, I would say there's a decent amount of Algebra 1 review in chapter 2. Okay, because we're going to be, going back and remembering how to do slope, how to write an equation of a line, things like that. Okay, but before we get into that, we're going to talk about functions today. So relations and functions, what it means to be a relation, what it means to be a function, and all of that. I think you guys will kind of like this one. I'm trying to remember, I don't think there's a whole lot that tricks you guys up in this lesson. So definitions here. A relation is a set of pairs of input and output values. Now, that's the fancy vocabulary, right? A set of pairs of input and output values. What's the short of it? A relation is a list of ordered pairs. Okay, that's what a relation is, a list of ordered pairs. Now, when we have a list of ordered pairs, we talk domain and range. Do you remember anything about domain versus range? Domain are the x's, range are the y's. Or you could say domain are the input values, range are the output values. Or mentioned the x's. The range is a set of output values, or in other words, the y's. So just like x, y is alphabetical, domain range is alphabetical because D comes before R. So there's a memory technique if you need a memory technique there. And then the big one, a function. So here a function is defined as a relation in which each element of the domain corresponds with exactly one element of the range. So each x value pairs with one and only one y value. Now, the short of it, you see what's in parentheses there? The x values don't repeat. Okay, so you don't have a 2, 5 and a 2, 8. Okay, that x can only go with one y. So that is definition of a function. We're going to talk about some examples down here and how to know if they're functions or not. Do you remember the vertical line test at least? I'd like to think that's one you might remember. First of all, vertical. Which way is vertical? Okay, good. Up and down, right? Up and down is vertical. Vertical line test is a method to check and see if a graph is a function. Given a graph that is a function, a vertical line can only pass through the graph one time. So if it passes the vertical line test, a single vertical line drawn will only touch the graph once. If it touches it more than once, it fails the vertical line test, and it's not a function. So again, we'll practice some of those. A function rule is an equation that represents an output value, y, in terms of an input value, x. We often, you guys are familiar with the notation f of x, right? Which notice right there, it says function notation. That's what when we talk about a function rule, an equation that represents an output value, y, in terms of a single input value. And so we use f of x as that function notation. So when you see me write f of x, just realize, okay, I could always take that f of x out and replace it with y. Okay? So f of x and y are interchangeable in a way. In other words, if you have an equation solved, y equals, that's the same as saying f of x equals. And then good to know, independent, dependent variable, x is always your independent variable. X is the one that it determines itself, whereas y is the dependent variable. It depends on the x. It depends on that independent variable. For instance, time. Time is always an independent variable. It's always x. Can we adjust time? Do we have any control over time? Okay, I mean, time is time. We can't stop time and, make 5 seconds longer or shorter or something. It's, so it's independent. Now, dependent is what depends on that, okay? So, time has to pass if we're going to measure the height of something or a distance or whatever it might be. Okay, so x is independent, or another way to think, the horizontal axis is always your independent variable. The vertical axis is always your dependent variable. Okay, so that's a lot of vocabulary there. Let's jump to some problems. Hey, they're easy problems to start with. Very easy, actually. So, problem 1. What are the domain and range of these relations? So, reminder, what's the order in an ordered pair? Always x, comma, y, correct? Mm-hmm. Every single time. So if that's correct, the first thing we're going to do is they asked us for domain and range. Let's start with domain. Now, when I list a set of values, I use what I call a brace, which is like a squiggly parenthesis. I don't know. Do the best you can to draw it. It doesn't have to be perfect. Yeah. I have good ones. I can draw them sometimes I can't. But okay. Thoughts on what my domain values are going to be in this problem?
0, 4, 8, 12, 16.
Okay. Justin says 0, 4, 8, 12, 16. And why did you pick those, Justin?
Because those are your x values.
Okay, so they're my x values. So I'm just going to list them with a comma, 0, comma 4, comma 8, comma 12, comma 16. Okay. So those are my domains. Those are my x values. Now, we are also asked to state the range. Justin's not allowed to answer this time. Sorry, you're vetoed this time. You've got enough other classmates in here that can help you. What are my range values? I mean, if he did the first one, come on. He's making it easier on you. Cam?
5,904. 7696. 8976. 9744.
Okay. I start to say, where is he at? And then I realize you just read them backwards.
Yeah.
Now, and actually, in this case, by reading them backwards, you actually went in numerical order.
Yeah, that's right.
Okay. Now, and I was going to write them in forwards order. Honestly, it doesn't really matter. Okay. So he started with 5,904. I normally start with 10,000. It doesn't matter. Okay. What order you write the numbers in isn't going to matter. But notice he listed all of the y values, didn't he?
Yes.
10,000, 9,744, 8,976, 7,696, 5,904. Questions on that extremely difficult problem? A little sarcasm there.
Can I answer the next one?
Are you going to have any of these on the test?
Yeah.
You might.
Can I answer the next question?
You guys want easy ones, right?
So I can't answer it all.
Yeah,
Not right now.
You can't answer.
I didn't say not the rest of I'm not saying the rest of the day. I'm just saying not on this one at least, okay?
She booted you.
Okay. So, example B now. Same questions, domain and range. I'm going to shortcut here and say D for domain. Now, it can't be Justin. It can't be Cam. So we'll just eliminate people as we go here. Domain. Jocelyn?
3, 0, 2, 9,
You got it. -3, 0, 2, 9, and 23. Okay. Range, Mac?
14, 7, 0, -18, -99.
Okay. 14, 7, 0, -18, -99. And I guess I didn't really state. You guys okay with it?
Mm-hmm.
Domain, she did the X values. She did the first item in each ordered pair, right? Range, she did the Y values, the second item in each ordered pair. We can handle that stuff, right?
Mm-hmm.
If only it was all this easy, right?
Mm-hmm.
That's what we really want.
Mm-hmm.
Okay, so example 2, or problem type 2. We've got 4 different problems we're going to go through here, and we want to know, is the relation a function? Now, I don't know how familiar you guys are. These are called mappings here, and what's happening is it's taking the domain bubble, so to speak, and it's mapping and pairing it up with the values in the range. I don't know if I should use the word bubble or what it is, but that's the word I came up with today. So, thoughts on whether or not this is a function? Lexus, you're shaking your head yes.
Yeah.
Why do you think yes?
Because the numbers have like multiple arrows.
Okay. She's noticing there's no multiple arrows.
Yes.
So if there's no multiple arrows, what's that mean?
Each number has. There's only one number per
Yeah.
number.
One number per number.
So it has
I want to say bad explanation, but then again, I get it. One number per number. Do you all get it?
each number has their own part.
Yeah. Each number has their own partner. There you go.
There are no
Okay. No duplicates. So if I go through and I write the ordered pairs, -3 pairs with -2.
Yes.
So if you have any question, if you don't like one of these explanations that we've come up with, here's what you do. -3 pairs with -2. 0 pairs with 7. And 4 pairs with 1. Are each of the x values unique? And they are.
Yes.
And so for that reason, we will say that yes,
Yes.
this is a function. Question or the next one?
No, I was just going to say the Y's can repeat, but the X's can't, right?
Correct. Yes. Y values can repeat, x's cannot. Yep. Okay. B. We have another mapping, or another, I won't call them bubbles, but you know. What do you think, Maya?
I would say no because 2 repeats.
2 repeats. She says no because 2 repeats. So, and here's what I do for proof. If you're not sure, write down the ordered pairs. What's that 2 represent?
The X.
Yeah, 2 represents x, and it goes to -3y value, and it goes to
A -1.
a -1. I don't have to write the rest down because what do I know right now?
X repeats, therefore it's not a function.
Okay. X repeats. It pairs with 2 different x values.
Yeah.
It paired with -3. It paired with -1, and that's a no-no. So we're going to say that this is not a function. Okay, you're okay with the mappings?
Yeah.
I mean, really, you can write them out as ordered pairs if you don't like them, so. Okay, C. We have 4, -1, 8, 6, 1, -1, 6, 6, and 4, 1. Does this set of ordered pairs represent a function? Mark, I think I saw you shaking your head. What are you thinking? Why not? Okay.
What are they?
Yeah. What's happening here? What number's repeating?
4.
4. First of all, 4 goes with -1. Then 4 goes with +1. So this is
Not a function.
not a function. 4 is paired with 2 different other numbers. So not a function. Now, let me ask you a what if question. What if 4 had been paired with -1 in both cases?
It is a function.
It is a function, right? Because if it's 4, -1 and 4, -1, it's paired with the same number, isn't it?
Yeah.
It's just listed twice.
Yeah.
So sometimes they'll throw that trick in on you. Just an FYI. Okay. D. -7, 14, 9, -7, 14, 7, 7, 14. That's a lot of confusing numbers there. But The question just stands, is it a function? I'm going to have to go back to Justin for a moment. He's dying here.
Yes.
Yes, it's a function. Why?
Because there's no repeating x values.
Okay. Each x value is unique. -7, 9, 14, and 7. Does it matter that there's a +7 and a -7?
Mm-hmm.
No. Does it matter that I have multiple 14s in the y?
No.
No. So, yes, this one is a function. Good. By all means, I try and make little markings and stuff, but make notes on your paper if you need a verbal explanation, you know? Write something down so you know. Okay. Same question. We want to know whether each of these graphs are functions. What's our technique here to determine if these are functions? Okay, so we're going to be using, or at least that's my choice of method, the vertical line test. Okay, because we're looking at graphs and we're looking at pictures, we're going to use the vertical line test. So, let's look at A and talk about A and how the vertical line test works with A. Do we remember? Maybe, maybe not. What do you remember, Lorna?
You just put a vertical line somewhere on the graph and then 2 spots with the graph.
Okay, so I put a vertical line somewhere on the graph. In this case, I drew it there. What just happened?
You touched.
You touched 2 points.
I touched that sideways parabola in 2 different spots.
So therefore it's not a function.
So it fails the vertical line test, and it is not a function. Could you maybe draw more than one vertical line if you need to check multiple spots?
Yes.
Yeah, you can.
Absolutely.
I mean, once you find one place it fails, though, you don't have to check anything else. Okay. So B. We have an absolute value V graph here. Not that you really have to know that, or not that that part matters. But thoughts on whether or not that one is a function.
It's funky.
Okay, Trevor, it's funky, but is it a function?
Yes.
Why?
Because there's not a spot where it touches twice.
Yeah. So if I pick a spot, okay, I'm going to pick a spot over here. Notice that one just touched once, didn't it? What if I go over here and draw a spot over here?
Then it touches once.
It touches once, right? You can draw as many lines, you know, not that you even really have to draw the lines, but each vertical line touches once. That's fine. So that means that, yes, this one is a function.
It's
Is that your vocabulary there? Funky for function? Okay, C. It's a little different, but it's still the same concept. Is it a function, as in does it fail or pass the vertical line test? I don't know. This one's different. What do you think, Lance?
I'm going to say it fails because there's a dot under the other dot.
I'm assuming you're talking about right here, aren't you?
Yep.
And right there, those 2 dots are on the same vertical line, aren't they? So that means that this fails the vertical line test. Now, it would work every place else, wouldn't it? It'd pass the vertical line test here, it'd pass it here, it'd pass it here, but it fails it in one spot,
so therefore, no.
it fails. So not a function. Okay. D. Nice little circle there. Well, at least I think it's supposed to be a circle. Looks like a circle to me. Close enough. Is this circle a function? What do we think there? Is Hunter trying to go to sleep on me back there?
No, just wait.
Okay, well, I'm going to make it your turn. Is this?
No, it fails.
Okay, it fails
Yeah.
because,
Because it's the line.
yeah, I picked that random spot to draw my line. So this is not a function. Okay, and E. I'd say this is probably like this could be a couple
It's a
different types of
squiggle.
graphs. A squiggle. My brain's trying to think, okay, it could be a cubic, it could be a sine or cosine graph, but for the purposes of this, it's a squiggle. I agree. We don't need to say anything else other than it's a squiggle. Hey, Braden, what do you think about this squiggle? Is it or is it not a function? You think it's a function?
Yes.
Let's see, I can draw a vertical line there. I just hit 1, didn't I?
Yes.
I can draw a vertical line there.
Yes.
I can draw it there. So yes,
Squiggle.
it is a function. Okay, is this a good review? Is it coming back to us?
Partially.
Okay. You got what you need?
Squiggles, yes. I hope that's
Probably not.
You say squiggle every time I hit
really
you. With this.
goal.
Okay, example 4. For the function f of x equals negative 2x plus 5, what is the output for the inputs negative 3, 0, and 1/4?
Numbers.
Now, a big part of the battle on this problem is how do we, what are they asking?
The output.
Because once they ask it, it's a very easy problem.
They're asking for the output.
What do we mean output?
Well, that's weird. That's just what the question is
Okay, I
asking
agree.
for.
I mean, they're asking for the output, but what do we mean output? What is output another name for?
No.
Don't find the y, which is the fx.
Okay. Well, when they ask for the output,
They want the
they're asking
Y
for the
value.
y's,
'Cause
which
it's
y is another name for
range.
range, f of x. Okay. What are they giving us there?
An equation to solve.
Well, they're giving us an equation, but what are these numbers? They're giving us inputs, which are
X.
x's. Are we helping to decipher what they're asking? That's the hardest part of this problem.
Then what's the
Other than
Y?
the fact they give you a fraction too. But
Then what's the Y value?
so if I think of this, you guys are familiar with like XY charts, right?
I forget them. Yeah.
Except I just made an f of x chart. Negative 3, 0, and 1/4 are going to go in the x column, yes?
Yes.
Those are your inputs, your x's. We're trying to find the outputs. Now,
Don't know which post goes on that.
f of x equals negative 2x plus 5. What that means, so the first one we're going to do is negative 3, right?
Y equals.
You can think y equals, or I just put f of negative 3 equals negative 2 times negative 3 plus 5. So every place I see an x, I replace it with
The X value.
negative
number.
3, or at least this time through. Okay? Now, you're just working on the right side. It's like that left side already says y equals. So, how do I do negative 2 times negative 3 plus 5?
You do negative 2 times negative 3.
And negative 2 times negative 3 is,
6.
and then
You add 5 to it, which is
6
11.
plus 5 is
11.
11. So when you put the input in of negative 3, you get an output of
11.
11. I promise that's not horribly difficult.
It's easier than I remember.
Okay. Am I done with this problem? Do I get to move on to the next one?
No, you have to solve for 0
No,
and
they gave us multiple
1/4.
So restart the problem. This time, every place I see an x, I'm replacing it with 0. So f of 0, negative 2 times 0 plus 5, Whoops, not sure why I put a parenthesis there at the end other than I got parenthesis happy. No better answer. Okay. Negative 2 times 0 is
0.
0, and 0 plus 5 is
5.
5. And we got to do one more, right?
Mm-hmm.
Your favorite.
Mm-mm.
Okay, everybody but Justin's favorite?
Mm-hmm.
I was going to deny it, but.
Keep going.
Okay. F of 1/4. Okay. You can at least start it, yes? Don't let the fraction scare you. Every
already
place I
know.
see an X, I'm replacing it with
1/4.
1/4. So negative 2 times 1/4 plus 5.
Do you have scissors? Because this is kind of.
Can we deal with it here in a little bit, or do you need it right now?
I mean, yeah, I can wait.
You're kind of interrupting my lesson here.
I know.
Negative 2 times 1/4. How do I multiply negative 2 times 1/4?
Make it negative 2 over 1.
Okay, so official answer there is negative 2 over 1 times 1 over 4.
Gives you negative 2 over 4, which equals 1/2.
Or there's a handy dandy device called a calculator. Nah.
I like the old fashioned.
You know what, guys? There are
piece of paper.
times you cannot use a calculator. So,
I like the old fashioned right down on the paper.
negative 2 over 1 times 1 over 4. If you multiply across, it's negative 2/4,
Yes, which is also
but reduces to negative 1/2
plus 5.
plus 5. Now, how do we add a positive and a negative?
You just.
You
When you're
subtract.
trying to add them, if you add opposite signs, you actually subtract them, right?
Yes.
So think logically here. Negative 1/2 plus 5 may be a bit confusing, but what's 5 take away a half?
4.5.
If I have a $5 bill and I spend half a dollar, I now have
$4.5.
$4.50. Now, however, Math Excel never wants 4.5. I can guarantee that. Maybe they'll take a decimal. How do I make this improper?
Multiply the 2 times the 4, add the 1.
Good. 2 times 4 is 8, plus 1 is 9 over the original denominator of 2. So 9/2. Okay. Now, you know, that was kind of a multi-step. You might not necessarily have 3 problems all in one there. So. Okay. So do you know what to do for part B then?
Yeah.
This time they changed the function on us, right? For f of x equals negative 4x plus 1, what is the output for the inputs negative 2, 0, and 5? So break it down for me. Again, it's asking for what is the output. So that means they're asking for
The y value.
the y values. And what are they giving me?
The x value.
The
So
x's.
make a chart and put in your x value.
So you can make a chart. You can call it an XY chart. Or you can say x f of x. And we're going to take this new equation. Every place I see an
X.
x, I'm going to replace negative 2. Negative 4 times negative 2. 8 plus 1.
9.
9. Did I need to write that workout? I didn't. Sorry. The next time, what are we doing?
You're doing f of x.
Next time, we're going to put in 0. Negative 4 times 0 plus 1.
0. 1.
Negative 4 times 0 is 0 plus 1. Ooh, tough math.
1.
0 plus 1.
3.
And then we're going to put in 5. Negative 4 times 5 plus 1.
Negative 19.
He says negative 19. Negative 4 times 5 is negative 20. Negative 20 plus 1. When you add a positive and negative, we subtract. 20 is bigger and negative. Negative 19. Okay. Couple of word problems to finish the day off.
Can I skip one?
Nope.
Darn it. What a shot.
Step number 1 in a word problem.
Figure out all your numbers.
Figure out what it's asked. What's the question?
Read it.
Yeah, read it. Okay? In order to do it, you've got to read it. Some of you guys skip step 1 and then get confused.
Yes.
Tickets to a concert are available online for $35 each plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? And then after we answer the problem, later we'll evaluate it for 4 tickets. Right now, we're going to work on the function rule. So let's look at what we have here. Tickets to a concert online for
$35.
$35 each plus
A $2.50 handling fee.
a $2.50 handling fee.
So
Does that say
that's
each
okay.
also?
No.
No, it's just a flat $2.50 fee.
So,
Whether you have 1 ticket or whether you have 100 tickets in that envelope.
so
okay.
we need to write an equation. F of x equals 35 times x plus 250.
Right idea. Okay. Notice it does say, and Justin here just used f of x. For my purposes, it doesn't matter what letters you use. Math Excel, if they give you letters, you have to use their letters if you have to do something like this, right?
Yeah.
Now, what I was going to look at is what do we need letters for? The total cost. So I was going to say C for cost is a function of the number of tickets. So I was going to use T for tickets.
So C.
Again, am I saying Justin's F and X are wrong?
Yes.
No. Okay, I am not. So,
Somebody else. Not
when it wants a function rule, we're finding an equation for the total cost, right? So the total cost is C. Kind of like f of x, I'm actually going to write it as C of t, though. Again, if you just write C equals, I'll be fine. But official language, C of t. How do we find that cost? $35 each, so 35 times t plus 250, 2.5. This satisfies the first part of the request. Because the first request was what is a function rule for this. Now, am I done with this?
No.
What does evaluate mean? Okay, put the number in and work it out. Evaluate it, get an answer. So what am I putting in?
4.
C of 4. So 35 times 4 plus 250. 35 times 4 is
140.
140 plus 2.5 makes it,
142.5.
and it's 142.5 what?
Dollars.
Yeah, so really $142.50. Okay,
Now we're done.
real quick. Look at the last one with me. You're buying bottles of a sports drink for a softball team. So Justin is buying bottles of body armor for a football team. That's what's going through Justin's mind, okay? Makes it applicable to him. Each bottle costs $1.19. What function rule models the total cost of a purchase? Now, we'll worry about the cost of 15 bottles here in a moment. I need a function rule, yes?
Yes.
What are we writing a function rule for?
The total cost.
Cost. So I'm going to do C for cost again. What is it that we are...
Each bottle.
Yeah, this time we're talking about bottles. So I'm going to use B for bottles. You don't have to use the same letter as me. These are my letters. If you want your letters, go for it. If you want to be the same as me, that's fine too. Now, if you're saying, I'm not sure how to write this in the equation. Okay. If you go into the grocery, the gas station, whatever, you're trying to buy drinks, you know that each bottle costs $1.19 and you need to know if you have enough money. What are you doing here? Mathematically, what are you doing?
You're going to take $1.19 times how many bottles you need.
Okay. If you need 10 bottles to have enough for your teammates, you're going to do $1.19 times 10, right?
Yes.
Yeah.
So if I'm writing my function rule, I'm going to use C of
CFB.
the cost based on bottles. And what am I going to do? $1.19 times
B.
B for this. This is my function rule. I'm going to evaluate it for 15. So I'm doing C of 15, which means we're doing 119 times 15, and the calculator answer is
I don't have it.
1785. That's $17.85. Okay. Your homework is in lesson 2.1, and it will be available on Math Excel.
So do it.
So do it, yeah. Hey, start this chapter off well. We're looking at midterms come this Friday, I believe. We're already going to be halfway through the first 9 weeks. So, you know, you don't want 0 homework scores. Okay? You don't want zeros, you don't want lows for homework scores.
I'd be like,